start this session early, and this will be the last session. So I request hand over to the Mr. Ashok Kumar, our colleague, for yeah, you can come here, sir, and then you can just do the moderation. Back to you.
Thank you, Pathak ji, for this particular panel discussion. So the topic for this panel discussion is transition towards AI native 6G networks. So we started talking about AI in telecom. So in fact, it's not 6G, but in 5G itself, we are now talking about all these aspects, starting from 5G advanced. And if you look back 2023, when ITU uh, came out with a framework and vision of 6G, and if you look at the usage scenario they talked about, and also the radio parameters, so you can see that they have already put in the vision document. For example, one of the usage scenario they have talked about uh, integrated AI in communications. So they have already talked about this. And if you also look about uh, integrated sensing and communications, so although it's a sensing along with communications, but definitely you need AI for object detection and all those aspects which we do related to the sensing. So it's already into the telecom. The second example which I can give you is the ORAN specifications by ORAN Alliance. All of us know the RIC, Radio Intelligent Controller, XAP, RAP, and those aspects which are already part of 5G and definitely will improve in 6G. Uh, so be it mobility management, be it energy management, be it quality of service management, all these aspects are already being thought about. Even the orchestration part, a lot of orchestration even in 5G is using AI. So what is changing in 6G, right? So why we are saying native AI? So whatever we have been talking about right now was sort of an afterthought that can we use AI onto the network or onto different component of the network. But in 6G, we want to design considering AI will be part and parcel of 6G. That's why people are calling it AI native 6G. So there are two aspects of it, like uh, AI itself will transform the telecommunication network. Second is the network has to be designed to support AI applications, right? So both aspect has to be looked at while we talked about. So to proceed further on this particular topic, the format which I'm thinking is like I can request speakers one by one to just talk for 2 minutes on their area of expertise, and then we start a panel discussions. Yeah, so maybe do we have a separate mic so that everyone can talk from the that itself? Okay, in case we have, or it's there. Okay, it's there. Okay, thank you. Okay, it was already there. Or maybe, so maybe I'll start from Professor Mahesh. If you can, maybe I request Professor Mahesh Marina ji from University of Edinburgh, UK, to talk about whatever expertise you have on this particular topic. So maybe 2 minutes or 3 minutes.
Should I?
I'm asking Professor Mahesh.
Yeah, this is me.
Yeah, okay.
So, firstly, thank you for this opportunity to be part of this diverse group of experts to provide an academic perspective. So, my interest related to this panel is more on how AI can enable efficient and automated operations, and that's an area that I have been working on for the past several years. But increasingly, I'm looking at also the flip side of how the network can play a role in providing a platform for AI compute, both for uh, workloads that are currently realized in the cloud, as well as applications on devices that are AI based and can benefit from the edge where the network comes in. So broadly speaking, my interests span these. In the context of AI for networking and AI for 5G, 6G, I've been looking at not just the opportunities, but also the risks that come with it and the implications on energy efficiency. So these are aspects that summarize my interests and expertise.
Thank you, Professor Mahesh. Now, may I request Dr. Elena from Ericsson to talk about your expertise or your domain of work?
Absolutely. Hello, everyone. In my domain of work, I've been working with AI technology and specifically AI research for telecom networks for many years. And obviously, as we know, there are many different kind of real-time characteristics and layers of the network. We started about 15 years ago applying AI, but it was more in the operational maintenance layers that don't require real-time characteristics. With years, we are moving into the core, into the radio access network, into the real-time management and controlling of the network. We've had the zero-touch vision, meaning full autonomy of the network as a main primary goal that we are striving towards. We also call it a cognitive network when it's not just automated, but it's also very smart, it's acting in real time, and actually doesn't require human intervention at all. So my expertise would be on that control loops closer to the radio network side, and of course, trustworthiness of AI will play an important role here as well.
Thank you. Do we have Dr. Simon?
I'm here.
Yeah, okay, sorry.
Yeah.
Okay, so I'm meeting for the first time, so
Yes.
yeah.
Yes, yes.
So okay, so over to you for your expertise, if you want to
Yeah,
say a
thank
few
you.
words.
So first of all, thank you for having me here today. So my pleasure. So I'm part of the standardization. So we are the people responsible then to enable the network, in this case, to leverage the full potential of AI, both integrating AI and leveraging what comes on top in terms of AI application. So this journey started already with 5G, which of course this also is seen as a more an evolutionary approach, the step that we are taking in 5G, because with the first 6G release, 5G release, it started to be late now. With the first 5G release, we were not having AI as the support of AI as one of the key requirements. Of course, we have been working and we are working then to integrate AI as part of the 5G Advance as over the top. So we are designing enablers in the network which will then allow AI basically to improve the performance of the network, both at the radio and both on the operational. So, for example, having solution for beamforming, for energy efficiency optimization, for mobility optimization, and so on. But I think with the 6G, we have a unique opportunity now that we start having the first understanding of what is needed in order then to make leverage the full potential of AI from the network side. And with the 6G, then we can really, let's say, look at design proper solution for AI for networks and the networks for AI, where AI for networks is definitely leveraged to optimize the performance of the network, the operability of the network, but then also network for AI. This is also how basically to leverage and how to enable to the AI application which come from third party. And this is also a unique opportunity that we should not miss from the standardization perspective, because these will be also opportunity for monetization. So that the CSP and that we are working with the CSP and the players to leverage from the AI ecosystem.
Thank you, Dr. Simon. Now I request Mr. Sandeep Sarmaji from Tech Mahindra.
Thank you, Ashokji, and blessed to be here on this panel. In my current role, I head the emerging technologies within Tech Mahindra. We are one of the leading system integrators around different stacks, and telecom is the leading vertical for us. In my interest areas or the role areas, I work regularly with different industry partners, how we integrate things together. And AI, as Alina was saying, is not something new. In networks, we are focusing more now, but as a whole, it is there for quite a decades. And IT world has seen it more closely since the networks are getting virtualized, more and more IT type of stuff is getting replicated, and we see a lot of reflections of experience that we have will be relevant in network space. Uh, 2 decades, I am purely a RAN guy, so it's mostly resonating what Elena and Simone has said. Uh, Having AI in the network is just to elaborate on Ramone. It's not. I have two different dimensions to it: network for AI, AI for network, and we need also have to have a network for AI models as well, because AI models are going to get distributed. We need to look at from that perspective. And as on today, industry is more focused on bringing optimization in the network performance using AI centrally is mostly north and south traffic. But as we evolve further, AI as a traffic will also need a different perspective how it needs to be treated, and use cases will also evolve in that dimension. So I'm exploring all these things, and additionally, in additional responsibility, I am also the vice chair of the Bharat 6G Alliance use case working group, and we closely follow how AI is going to impact the different use cases in the 6G space.
Thank you, Sandeep. Now I move to Dr. Aswin Humaste from Microsoft. As he's left. As is, no, sorry. Okay, so now I move to Ramu TS from Lekha Wireless. Yeah.
Yeah, thank you, sir. I'm co-founder and CEO of Lekha Wireless. Primarily at Lekha, I take care of 4G and 5G technology set of business. And we have a small team working on 6G. Primarily, we have been contributing to the 6G standardization. And personally, I have been in telecom for last 28 years. All along, I have been a physical air engineer and now wearing a hat of entrepreneur. So it's very exciting journey I see in terms of being part of this network and development of products in 4G and 5G. And always till probably about one and a half year back, I was having a opinion it's hard for AI and ML to get into the physical air part, and that's something which has transitioned the way we are talking of transition for AI native network as part of 6G. Even my thought process has transitioned along with my team who is working on 6G. We see today, like I have a team of experts who are working on the AI adoption as part of improvising handover, the mobility and also the enhancing performance through channel state information, as well as how do we see apply large language models and so on. So it's a very exciting journey because we have been developing products from 4G and 5G, now 6G. So there is a lot of transition that is coming up, both in terms of semiconductor, because there's the semiconductors are going to be with designed for AI, bring AI into it, as well as software has to be rewritten, the stacks has to be rewritten. So it's a pretty exciting journey, and like to look forward for a productive discussion here. Thank you.
Yeah. May I request Dr. Rohit?
Hello, I'm Rohit Budhiraja. I am a faculty in the Department of Electrical Engineering. And before joining academia, I worked in industry for 9 years or so. And so I've been working, designing these systems for last 25 years now. Worked on 3G, 4G, and recently we designed a 5G system as well, and whose technology was transferred also to Tejas Networks. Now, in context of this panel discussion, I've been working in AI for like now last 9 years, wherein we have been working on the models which we can understand, which is basically probabilistic machine learning models. And I primarily work in physical layer, wherein whatever problems are there in physical layer, we are interested in solving using AI. And so the probabilistic machine learning is basically we focused on Bayesian machine learning part. And I've been teaching a course as well on machine learning for wireless for last 5-6 years now. And so it's like applications of machine learning to wireless, and how can we build these probabilistic machine learning models. Now, 4 or 5 years, I jumped the bandwagon and started building these deep learning models for physical layer aspects. So these are like deep learning, and probabilistic machine learning is my area of interest, and we do extensive work, and I'm closely coupled with standardization also. So that's my research interest. Thank you.
Thank you, Rohit. So let us take it forward. So I think now our participants knows who are expert in which area. So please keep your questions for the panelists ready. So maybe I can start with one question of mine. So I think none of you talked about, if I not missed, about the role of agentic AI. So today a lot of talk about agentic AI for automation of various processes, decision making and all. So this question is for anyone who can pick up from the panel, that what could be role of agentic AI and how it can solve some of the problem which we have in telecom. Any of you can pick this question?
I can start.
Yeah, please.
What I mentioned in the beginning, that we have different layers of orchestration in the network, of course. Everything from the planning into the millisecond layers in the radio access network and the scheduler. Agentic AI is applicable on all these layers. Then the higher we are, the less real-time characteristics we are facing, the easier it is to apply. Agentic AI is not a rocket science, it's a smart orchestrator that's in itself facing the foundation models that are built from different types of data, not necessarily language. And that is more tricky, because for telecom data, we can build models of different types and sizes. So coming back to agentic, we're using it in many different networks layers already. There are fantastic frameworks out there. The interesting part that is, of course, when you manage the network, and imagine that you're running operations in real time of a network, and then you're running some kind of, and again, we are striving towards full autonomy. And if you're running some kind of digital twin of a network and you want to execute some plans, or maybe you detect automatically that maybe something is about to degrade or something, and you want to play different scenarios. Why is that happening? That means that you need to pull data from different parts of the network and execute several what-if scenarios on the fly, maybe even in parallel, and that's your agents. And that is absolutely applicable on different layers of the network. And the trickiest one would be, of course, closest to the heart, when you have the millisecond constraints and you want to deploy the best scheduling strategy, for example, or the best ray tracing strategy. And for that, you will need to have real-time agents. So totally doable. The level of trickiness is varying depending on the real-time characteristics.
So thank you, Dr. Lena. You already said that it's already being used in different layers of a telecom network, agentic AI, and it can do much more, perhaps in coming 6G. So okay, let me start with Professor Mahesh. One questions, rather twin questions. That so what is difference between AI enabled network and AI native network? That's question one. And a connected question is that when we use AI native architecture, so what exactly we are changing from the current network architecture? That's the question. Oh, sorry, I'm very confused. Yeah. Yeah.
Okay, so let me first take the first question. If I understand it correctly, the distinction between what is AI enhanced versus what is AI native. Uh, at some level, we have been relying on AI enhanced mode uh, even in the 4G days. So there is something called self-organizing networks where you take the data from the network to aid in certain operations. And in that era, it would be more about rule-based algorithms. And in the current 5G networks, there are a number of these agents, we can call them, which are focused on particular tasks, be it energy efficiency optimization or load balancing or handover optimization and so forth that operators rely on. And they have AI capabilities on them. So these are um, fragmented add-on capabilities to achieve certain efficiency gains. Going to the AI native world would mean a deeper integration of these capabilities and unifying them, going away from this fragmented view that we have today. And I think that also links with what Elena was talking about, where you have these different agents. Currently, they are very fragmented, but in the future, there is an opportunity to bring them under a unified framework. So that is one way to look at AI native, in my view. The other is to do with the compute itself. So today, with respect to AI in telecoms, the compute is again not set up for AI across the stack, and this will be a key enabler for leveraging AI at other layers, at faster time scales, and to do physical layer communication, leveraging AI. All of these would require evolving to a fabric which is AI suitable. So this is for the first question. So the second question
Yeah.
is,
I like the question was like we are talking about AI native architecture. So fundamentally, what changes is going to happen from a normal telecom architecture to a AI native? I think the first answer itself you covered that. So thank you. If you want to supplement something, yeah.
yeah, I think maybe I can say the things to keep in mind. Obviously, every time we talk about AI, I think it is useful to think about three dimensions. One is the data, the second is the compute, and the third is the intelligence in the form of algorithms, models, and so on. So data is key enabler, and streamlining access to data across the stack is one new thing that needs to come in. And today, it is still very much limited by the APIs that vendor solutions provide, but this could be evolved to make it more richer and more flexible. And compute I already commented on. And then the software architecture and the applications in the sense of models that rely on this. I think this, there is a whole set of things to be looked at there to, again, arrive at something harmonized for key components where it can form the platform to enable these AI capabilities on the network. I think I'll leave it at that.
Yeah, thank you, Professor Mahesh. So I can open the floor for any question for Professor Mahesh from the audience. You can raise your hand. We can reach out to you with a mic. Okay, so there is a raised hand. Can you?
Yeah, perhaps you can introduce yourself and ask your question.
Hello, sir. I am Hardik from Life Tech Elevation. So we are working in unmanned aerial vehicles and the 6G spectrum in the remote areas. So my question is that how AI is integrating the sensing and communication in AI in 6G particularly, and how good is Indian telecom system ready for enabling AI services in it?
So, okay, I think I can open this question to anyone in the dais. Maybe Professor Rohit can try and answer. Yeah.
Yeah, so he is asking very deep questions for which we don't have an answer as of now. So if you look at 3GPP, we are basically starting to study all this. And we are going to study it for another 2 years, by the way. And so difficult to answer this, but I'll try answering it. Now, so what you are asking, how AI will enable integrated sensing and communication, that's your first question. So integrated, see, sensing has been done by radars, okay, for, I don't know, for 50, 60, 70, 80 years. Now we want to integrate both these systems together and then see whether we can reduce the cost of installing these systems for the operator. That's what we are looking at and making systems simple. Now, can AI, so just to answer your question, can AI help us in designing these waveforms, combined waveforms, which can basically reduce the cost, which can do better detection, which can help us in, let's say, you need high accuracy for certain kind of applications. Can AI enable us in doing and achieving that accuracy? So can it help us in doing all that? So that is how AI can help us. But how much of gain we are going to get, that, as I said, you'll have to wait for another 2 years. That is there. And now you are talking about Indian telecom. Perhaps none of us is ready as of now to incorporate the AI into our existing network. And that's what we've been talking to government, that we need to build systems to see how much of actual gains do you get. And you need to build these systems to see, like, inference, how good inference you could do. And the thing here is, now we are talking about this like energy efficiency, okay? We want our 6G networks to be energy efficient. AI is energy guzzler, right? So these are two conflicting objectives, and I teach a course on optimization. There's something called Pareto optimality. Now, there are two conflicting objectives. Okay, you want to use AI to improve performance, and on the other hand, it's a energy guzzler. Can you achieve both these objectives? Yes, there is a sweet spot, and that's called Pareto optimality. We can do that, but in order to do that, we need to. It's not simulations are not enough. We need to build these systems to show it to the telecom operator that it actually works. You need to sell these systems to them. So we need to first demonstrate, we need to build proof of concept AI-based systems. And then if we can show that, okay, this works, then of course telecom operators will also be interested.
Thank you. Anyone want to add?
Yeah. I just want to add one more perspective to this question. Primarily, since you raised unmanned aerial vehicle as a more communication for UAV, say today we have certain algorithms which are trying to optimize. You can put them as a non-collaborative AI. There are things which network is doing for a moving object to make sure communication link is intact, right? So I'm talking primarily from the physical air perspective. There are multiple things that has to happen. So as we migrate from the current networks, the 4G and 5G network, which is implementing certain algorithms, which is based on learning, but it is very static, it is not dynamic, right? So we are going to transition from non-collaborative AI where the device takes certain decisions based on its learning and network takes certain decisions based on its learning. Many times it could be conflicting, right? So from here we'll move towards collaborative AI, and probably a native AI will come down the lane as part of 6G. So this is the journey, right? So today, if you ask me, is Indian OEMs ready with the network? Yes, we do have the state-of-the-art cutting-edge networks, but these are going to transition from where we are to the true native AI functions as we move towards 6G. That's the primary goal. Yeah, thank you.
Thank you, Professor Rohit and Ramuji. Maybe my next question is from Dr. Elena. I think you already answered one question related to agentic AI, and there you talked about the autonomous network, how we can automate the various layers of the network using the agentic AI and other stuff in the AI. My question to you is like, how can we balance autonomy with control in AI managed network to ensure safety and reliability in the sense that, so can we completely rely on AI for safety, reliability when we automate the network with AI?
So I'm going to give a short and boring answer. Yes, I think my vision is that we need to be able to rely completely on the full autonomy. And then another boring side of the story is that, of course, we need to work a lot with the AI trustworthiness from the start. So it's not you know, choice. It has to be there from the start. And it's interesting how you ask about agentic, because now it's kind of the newer technology and so on. But I think in telecoms, we need to be prepared to bring in any kind of new technology. We need to be that flexible in telecoms to bring in new AI methods into our systems really quickly, so that our systems are not lagging behind. And telecom networks are there for all these new methods and for AI. It's a key component, of course. So how do we balance autonomy with control? I mean, replacing human effort with AI, and you can discuss everything, and we can build all these trustworthiness and explainability methods where you prove that it's actually absolutely non-dangerous and the network will not fail. But in practice, when we go to real-time aspects and we are actuating on milliseconds, you cannot have a human in the loop. Because when you're going to be executing a real-time digital twin of a network, and the decisions are happening there in milliseconds level, so we cannot have a human. So unfortunately, and I know that it's not a popular thing to say, but we cannot. So instead, we need to have, of course, we need to have guardrails. We need to make sure that any action is within specified rules that we have dictated in the beginning. If we are replacing a classical rule-based algorithm with an AI algorithm, it needs to be only acting within these boundaries and so on. So, I mean, maybe a boring answer, but all of this needs to be done, and we need to set the boundaries. And then in many cases, there won't be any human in the loop. It will be full autonomy.
Yeah, thank you. So you said that we need to set the boundary for AI to work, and then it will be fully autonomous in that boundary, right? So thank you so much. Yeah.
So I think one thing, completely agree with what Elena said. One thing I would add from a safety and reliability point of view is the notion of intent. I think that would be key to use as a guide to be able to serve as a reference to monitor the operation of the network, and of course explainability, interpretability is important. And on top of that, having this red button option where you fall back to a safe mode, and that can sort of give a higher level of safety and reliability.
Yeah, thank you, Professor Mahesh. So any question for Dr. Elena from, audience? Yeah. There is a raised hand on the back. If someone can give mic.
Okay, so I'm Rajesh. I work for Device Research. So, interesting answer. It's not boring, of course. But I guess, I would like to hear your views on what you described is all about trust, or is there something beyond that? Like you mentioned about explainability, right? That's an important aspect. And how do you see trust percolating into standards. What is your views, in terms of how you can incorporate standards or how you can incorporate certain things in standards that make networks more trustworthy? And second question is, there are going to be billions of devices now being connected, right, in 6G, and thousands, or I don't know, even hundreds, thousands of varieties of devices, right? So, and then there's a bit of a closed environment where people want to build AI intelligence in the devices. And what are the challenges that you see from standardization perspective to build trust even with devices and network communication, just not in the network itself, but also in the end-to-end perspective? Sorry, a bit complicated question,
Thank you. Let me try to answer this one. First of all, I think a challenge is, of course, it's challenging, but then the way you see it, I mean, we are in a complex industry and we love those challenges also. And I totally agree with you that those safety and trustworthiness need to be propagated all the way to standards. And then standards help us, in a way, to define our trustworthiness frameworks so that we can automatically verify that the system adheres to the standards. I know that there are several standards on trustworthiness of cyber physical systems and you're in device space, and specifically, I mean, I can just give an example. We worked on standards of connected collaborative robotics, and collaborative robotics is something that's connected and collaborate not between the robots, but a robot and a human. And that's a very clear case when you cannot afford the mistake, because industrial robots can essentially kill a human. And then when network is part of that, we also need to contribute to the standards and to make sure that we verify in advance that all parts of the system guarantees safety. So that's just one kind of example of that. Other examples that are acting on what I mentioned on millisecond level, that will be different methods of kind of standardizing and making sure that in advance, before you roll out, of course we'll have all the sandboxes, so of course we'll have the systems where you kind of test and so on. I come from software verification background before I kind of onboarded AI journey 15 years ago, and verification, making sure that it's formally guaranteed, certain guarantees are there, that's kind of part of my DNA.
Thank you, Dr. Elena. You want to add? Yeah, please.
Let me add, and thank you, Rajesh, for the question. So we didn't prepare it before. So maybe to complement to also what Elena said. So we define what we define in standard. So what we define as let's say interfaces, what we standardize as interfaces is done in order to support multi-vendor and or in order to support interoperability. We know that, of course, leveraging AI, we introduce adaptability. Already today, when we prompt the same question, we might get even different reply, right? So I think this is a key point, because we need to develop an integrate solution into the standard, which basically allow to verify the explainability. Because if the behavior on the specific interface becomes variable and it cannot be predicted, and then is not robust and reliable, then of course the performance will significantly degrade when there is a communication between components from different vendor. I think supporting the explainability of a result which is out of an AI-based function, I think it's very important. Of course, in standard, we are also enabling the option to fall back to a non-AI solution. So if we see that the performance on that specific interface, because maybe we are still in the learning phase and we are not yet, let's say, fully optimal in terms of performance, we can always fall back to the non-AI case. But of course, in this case, we will lose all the potential and all the adaptability and flexibility of that. I think that is definitely one of the areas where we need to find solutions who address the explainability.
Thank you. Okay, there is one more raised hand. Yeah.
Thank you. I have a question which you have not raised, and let us look at AI for RAN, right? And specifically data for AI, right? So if you want to get channel data or demod data, you have to get it from somewhere, right? You can use ray tracing, you can use statistical channel models, you can use generative channel models, you can use operated data. So without data, adequate data, what you get, if you want to build a digital twin of the RAN, it will be garbage in, garbage out. So what is your opinion, how to get this data or enough data so that I can build a digital twin of the RAN in this context? Thank you.
Anyone who want to take this question? Yeah.
Yeah. I go first. Okay. Thank you, Amitabha. Also, this question was not prepared, so it seems that my colleagues are interested to. Okay, but yes, I would say the issue that I think we have today. I mean, we don't have AI without data. I think this is clear, right? Data is the fuel for AI, and we need good data, quality data. Is maybe not about the amount of data, but is the quality of the data which counts. And what is also important is that we can use all the possible source of data that we can use then to build for example, the digital twin, or whatever other use case that we have in mind. The issue that we need to address is that the solution today is basically domain-based. So we get data from radio, we get data from the system, we get data from the core network, we get data from the management at the management layer, but all those data today are collected through different mechanisms, and there is no particular exchange of this data between the different domains, and there are no exchange of data between different vendors, for example. All those problems need to be addressed in order then to, it's not the amount of data, but it's the quality of data, and we need to have the capability to really have leverage the data end to end. So it's not, from my perspective, only specific. We need more data from radio, but it's really we need the data who is needed to build the full system. So, and that is really end to end.
Yeah, I think just to add, digital twin also have different dimensions. We all know it. For what purpose we are building digital twin, it also defines how much data that we can generate or take as a telemetry from current standards. As we go towards AI native wireless, I think that's a provision that we are discussing in different forums, that we need to have hooks defined at different layers itself, so that the data could be telemetered out from the network and could be used anonymously, or we could anonymize data across the networks as well. The biggest problem, as you rightly mentioned, is that we are living in a management of data paradox. We need data, but no one wants to share the data as well. For that to happen, we need to have certain open interfaces that should be standardized, and those open interfaces should be used as a hook to pass on data both in the east-west direction and the north-south direction as well, so that the more realistic digital twins can be created.
Thank you. I think taking clue from your question and also the answer, you know, to add. Okay, let me ask this question. Perhaps you can pick this question also and try to answer. So, so what I was thinking, like, so his question was that some of the data which is coming in the control channel is required for making the system AI native. You also talked about that the interfaces, standard API would be required to take the data so that AI can actually use to learn and make a decision. So my question to you or anyone who can pick it up, like that tells us that we need some standard, right? So whether something is happening at 3GPP level on this aspect, if any of you are aware, I think you talked about standard, that's...
I mean, this is, we need to design the proper interface which allows, open interface which allows. I think what is important is that we need open interface where we need. We don't need open interface everywhere, because still from the performance perspective, the proprietary interface still perform better than the open interface. But we need the open interface where, for example, we need to exchange and we need to have a multi-modem, a multi-vendor operation. And this is happening because For example, let me just bring two simple examples. So one is, and this is already happening in 5G because the SBA, the service-based architecture, has introduced the consumer and producer approach. So already in the 5G core, and this is already an open interface which can be expanded, for example, to also support on the core network the agentic AI. So if I have time, then I would like to address again the agentic AI question going back.
Okay.
But maybe let me move on this. Another interface, I was talking about 3GPP. Another interface is, for example, the R1 from Oran. R1 interface allows to third party to develop management application which can be plugged in the no real-time RIC and that can be controlled through the SMO services. So those are happening. Then we have, of course, API. We need to generalize the API for the exposure of the data, and I think this is also what standard is currently working on. So I would say, yes, we are working already on the open interface, but of course we should not now generalize that all the interfaces need to be open, because interoperability is also then a key requirement.
I think you have supplementary question.
So you're talking about standards, especially RAN 1. So you have these three features: beam management, CSI, and positioning, right? And all the simulations is based on statistical channel model.
Quadriga.
Yeah. And it is not based on ray tracing or generative channel models or actual data. So I don't know how to represent the actual network if I do my design based on statistical channel.
Yeah.
But-
So, as he's saying, Amitabh is saying, I'm an academician, so if I have to write papers, I use statistical channel modeling. And if I have to push something into 3GPP, I use Quadriga-based channel model, which is well accepted in 3GPP. So I do that. It is a wish that we have more realistic data coming from operators, but who's going to share that? Nobody. And now people are talking about these interfaces. I don't know how many operators would like to do that. Okay, that is one. So my take on that will be more provocative, and I say build it. Build the systems, have your systems, and then have your data. And that's what we are doing. We recently built a network, 5G network, and then we want to enhance it for all this AI/ML, and then see what kind of gains it gives. But we need data for that, and I think sharing data is a wish, as I said, but realistic data. So we don't have it. Most of us are relying on statistical data, but how far it can take, I have my own doubts. So I'd like to add a couple of points to this. So with respect to AI for RAN and the data for that context, there are, depending on the type of data needed, there are different kinds of RAN emulation or digital twins that exist already and are being developed. I think they could be, so to the extent that they are high fidelity, like the NVIDIA digital twin and so forth, so they can be a good source of realistic data. Secondly, for people who have access to or run sizable deployments of networks, not at the operator scale, but at a testbed scale. So these could also be a great source of realistic data. And in fact, in the context of ORAN, there's been a lot of work in the research world in terms of enabling technology which can allow for data to be flexibly collected through, like I can think of Janus is a framework from Microsoft, which makes us incredibly flexible to collect data from anywhere in the stack, including channel data. So these things, to the extent that they are standardized, they can be a great way to extract data even from operator networks. Of course, there is also the challenge of sharing data. One powerful tool is generative AI, right? So I have used this in my own work, where if you have a small corpus of real data, operator provided data, then you can generate realistic, unlimited amount of data uh, by doing a conditional generation. And we've done this for traffic and for drive test data and so forth. So that's a very powerful tool to leverage.
But I just wanted to ask you how this generative modeling, we also do a bit of that. But how much you can actually trust that? How much of the close it to realistic data? That's
So your
what
question
I-
is, his question is that synthetic data we generate using a small
know-
set of data, how much we can trust.
yeah.
So that depends upon, I mean, once you perhaps use it and see the reliability, that is the answer.
See, all
perhaps.
these
Anyway.
statistical channel models can actually help us in generating huge amount of data. That, with respect to the telecom or physical data, that's not the problem. Okay, I think yes, you can say there's another way of generating data using generative modeling. It's as good as okay, one is faster, one is slower, and all these.
But I think in this problem we are trying to find a way for a workaround for a business problem, because in this constellation we are representing telecom vendors, we are representing academia, we are representing integrators. But if only we had an operator here in the crowd, that's easy because an operator has the data. So the data, majority of the data will have to come from live networks, and they own it. And this is where the need will come. And every operator, even without waiting for standardization, if it is full observability, if it's AI native network, it means full observability. That means that you can build it. You can build it from day one. But the struggle is real for us. I mean, of course, we need to have models that are generic enough that you can use from many different vendors. But I think I'm suspecting that your question is not about technology, because technology-wise we know how to do it. It's more business model-wise and kind of how do we make it happen in the world. And then, of course, we can discuss all types of techniques like synthetic data, generalization, obfuscation, and so on. But it boils down to willingness and trust and how to share it among the community, right?
Thank you. So I think it boils down to, okay, let me take Sandeep Sharma ji, right? Because the question is coming to you, you being the system integrator, when you build system, you take RAN from one, core from somebody else, various component he has to like integrate. So the same challenge, like for example, even if you have an open standard like XN interface or X2 interface for mobility, but no two systems work even today, right? So my question to you is that, like, as a system integrator, what kind of challenge you face related to integration of the system, particularly if I talk about AI?
Sure. I think if I say it, I think we are putting too much of expectation on AI, honestly speaking, right? And I was listening to fellow panelists, okay, trust AI. AI is artificial intelligence, and we humans don't trust each other when we spend some time together. So I would say spend some time with AI. Let it get tested in the network, because we as an SI are using AI at the operational level quite extensively. We see positive results coming out of it. But when we talk about native AI, that's where the actual challenge comes in, right? When you talk about east-west traffic management, north-south traffic management, all happening together. For sure, certain interfaces needs to be there, comply to be there as well from different ecosystem partners. But having an open interface won't suffice. We need to have a right set of frameworks as well that we see missing today, so that the data exchange should happen more openly, more transparently, at the same time managing the privacy of the data. So certain data privacy mechanisms exist today. We can do data anonymization, and for certain specific test case, we're discussing the previous question of generating synthetic data, so that we need not to be exporting all those data for a central repository. But for sure, integration of AI in the telecom networks, to a certain extent, it's already there. Then we go deeper into the layer at the node level. That's where we need more, I would say, discussion on how the standards will allow certain interfaces realistically open.
Yeah, so again, one supplementary question, and in case anyone from, yeah, so okay, I'll give you the mic. Before that, For example, I was talking about X2 and XN interface, whether AI can a bit solve this problem in the sense that whenever we change certain API, like both party has to work together, it takes very, very long time to like again interoperate. So whether AI can solve this problem, that's the question. I just reserve this question and I take question from the audience also. Yeah, please go ahead. Both question you can answer together.
Yeah, I'm Dr. VN Sastri, working in IDRBT, specifically on the 5G use cases, mobile applications, and also mobile security.
Can you be a bit louder?
Yeah, so I have two questions. One is, see, when we look at the 6G developments, initiatives across, one is the demand side, one is the supply side, one is the speculative side. Okay, specifically when we look at what are the 6G use cases which are going to be the killer use cases from the Indian perspective and specific to the common man. If I could get some thoughts on that, it will be very nice. Second question is on the various types of mobile applications that we have across the world. There are several millions of applications. When we transition to the 6G based solutions, what skills are required for the mobile application developers to be ready to go for the developments for the 6G? So one is on the use cases, 6G use cases specific to the Indian perspective for a common man. And second, for the mobile application developers, what skills they should get prepared to go for the development of 6G use cases. Thank you.
Thank you for the question. I mean, anyone would like to? Yeah.
Yeah, if
Sandeep?
I understood correctly, definition of use case also depends on which context we are talking about. Identifying a use case much before technology, it is still a paperwork. Having said that, if you look at how the industry has evolved over the years, the traditional use cases were of a long life cycle. For example, the voice was the main use case, right? When come 2G networks, we are okay with the 2G because there are not much of expectation from the end consumers. But what we see today, as we're progressing with the AI is not only in terms of using it for automation efficiency as a use case, it puts a different requirements on the network itself. For example, certain packet loss of maybe 1%, certain inferencing could jeopardize, inferencing efficiencies could jeopardize up to 50%. So what type of applications that AI specific end use application that are running on the network that will be more specifically defined in 6G when you have a different KPIs running for different network elements. Other component is that don't think 6G is only AI, right? There's another component of ubiquitous coverage where end user get connected to all the time, either in remote areas or a ship and everything, or from the single device. That would be from the end user perspective. And 6G is not predominantly only end user from the subscriber perspective. Look for many different industry applications as well. So holistically, there will be a number of different use cases that get generated, especially the gentleman asked about the sensing. I think I have a different comments on sensing as well. Sensing is something which we can use it, leverage it in different forms. Maybe the initial release may not come as integrated, it may be disjoint. You need collaboration or data analysis on a central server, but when it gets integrated in the later releases, you may need more and more standards driven approaches as well. So different use cases can be elaborated more in 6G with the better efficiencies, and AI as a traffic use case will be much more efficient when we have a AI native 6G standards defined. That's my view.
Right.
I can comment.
Yeah, please. Yeah.
So on your second question about what the application developers may need to do differently with the future 6G, I think that's to some extent this is already kind of happening where at least the way I envision is a lot of these applications which are AI based, which might currently rely on the cloud for serving those applications. So they may need to be re-architected to leverage the edge. And that might require rethinking how these applications are developed. So in terms of the APIs to access the edge as a nearby computing resource to offload part of the AI compute for inferencing. This may be a new requirement that might come up.
Thank you. My next question.
Can you comment?
Yeah, okay, there is a raised hand. Let's take that question. A lot of interest.
I appreciate the session. Sorry, Mike Short, Chairman, UK Telecoms Labs. I appreciate the session is very much about networks, but nobody said very much about satellite or SATCOMs and NTN. Would you like to talk a little bit about how AI may help the journey of telecoms and SATCOMs to work together, but also perhaps acknowledging that systems like billing systems and customer care systems and provisioning may also be helped with the AI. But my primary point is SATCOMs. How will NTN be helped by AI?
Yeah. Who you want to pick? Okay.
I can answer part of that question based on my work. So within satellite-based communication, one very compelling application is Earth observation. So this is an area where communication is a bottleneck to be able to access this vast amount of image data to the cloud and store it. And so this we've already shown in our recent work that you can gain immensely by relying on generative AI to get orders of magnitude reduction in the communication requirement and also the storage costs, so that you can recreate. This is a bit like compression in a lightweight sense and recreating on demand to enable a wide variety of applications from that data. So that is one particular case. It is not quite the NTN, but it's still a SATCOM application.
Yeah, thank you. I think his question, anyone else want to pick that question? Yeah.
Yeah, I think NTN is going to be treated similarly where 3GPP standards are being treated. So all the use cases that we thought of, either from the perspectives of operations of the NTN networks, enabling the subscribers data, and at the same time a lot of LEO satellites are coming into picture and they keep on moving. How to predetermine via probabilistic modeling whether which area will get covered at what time, at what quality of coverage, could be another use case that AI can help.
Yeah, you're right. So I think the mobility part, when you have a LEO satellite always moving, so instead of a user moving, it's a cell moving, so that mobility itself, perhaps if you can solve with AI, will be a great thing for satellite to get integrated with terrestrial network. So thank you. Yeah, please.
Yeah, we are talking about mobility, and can AI help us in designing at the physical layer level, in handling this Doppler, high Doppler? Okay, it's a challenge, but can AI predict that and help us in designing a reliable system? That's, I think, one technology area where AI can definitely help.
Yeah, thank you. I think some of the problems are already solved in the sense that today we have Starlink satellites are moving away every 15, 17 seconds and you are getting coverage from the next satellite. Some sort of mobility aspects are already solved by some of our guys. So maybe, yeah, but the question is, now you have a double mobility, subscriber also moving, satellite also moving. Yeah, thank you.
No, AI is actually doing things better. When the problem is being solved, can we do it better using that? That's the question.
Thank you. So my next question is from Ramu from Lekha Wireless. I think he's the only SME in our panelist, and you are into RAN side, I suppose. So my question is that
just I think let me just only one announcement that Honorable Minister will be coming at this place only within 10 to 15 minutes. So you please continue. I am requesting not to wind up, but continue. Moment I will say, then we will wind up. Please. And we will have keynote address here itself.
So let me tell, he want to save his job, because if minister comes and hall is empty. So thank you. On a lighter note, yeah. So so my question to you is that I think you're on the radio side, so maybe air interface perhaps has to be designed on AI. Uh, so what kind of tools, skills, etc. do you need to actually incorporate all those aspects onto your radio?
So, yeah, thanks for the
Particularly
question.
this question is for SME because you may not have access to so many of the tools which are required to exactly work upon.
Sure.
So in that sense, this question is, yeah.
Yeah, I think, sir, as I mentioned earlier, say, as AI has penetrated into so many aspects of life, and probably now it's coming into the network, right? So, naturally, those who are already designing and developing network elements components, we are all going through one round of learning, right? How do we adapt? Because we know the benefits of the AI, how the machine learning can transform our design and development. There is another angle which is coming from a over-the-air interface where how network and device can collaborate. I think this is a subject of the standard. The standardization is going to come and help here. But when it comes to designing of the system, there are many things which we are looking at how we can adapt, where we don't have to really wait for 6G standard to come. Rather, it can actually improve systems in our current 5G advanced, 5G or 5G advanced systems. So, in terms of skills, I think the domain expertise will continue to exist. That is required. People have to acquire the telecom domain expertise, but the additional AI is something which is in the form of platforms, in the way how it is processed, the various models. So this is something which industry will look forward. And in fact, I'm also a student who's learning and trying to adapt the AML into the system, sir. Yeah, thank you.
Thank you. So all of us are a student related to AI today, as you said. Okay. So any question from our August gathering here? Okay. So maybe I take a question from Professor Rohit. So what research priority should India set to contribute strongly to AI native 6G standards?
I think I stressed upon it earlier as well that building an system, AI-based system, is extremely important for from Indian perspective. As I said, we are talking about the AI and the energy efficiency. These are two conflicting objectives. Can we build a system which will satisfy both these objectives? Okay, unless and until we do that, we are not sure. Okay, there's all these simulation-based studies can take us only that far. So we need to really have a system which can show us these gains. That is, I think, utmost priority, and that will help us in collecting data as well as we have been talking about that that nobody is willing to share data, right? And we can only generate data, but how much of realistic data we have. So if we lay priorities on that, I think it will help us as a nation, and it will help us in basically be ready to have this like the network which is by 29 which we want to build our own 6G network. I think that will help us in that direction. Plus I think we are talking about, I was part of another panel discussion as well. So if we can, people were talking about resilience. Okay, so if we can build a resilient network, that we have such a long coastline, we have been of late seeing disasters in the mountainous part. Can we build these resilient network which can help us, like when these disasters strike, then can our networks work? That's another focus we should have. Resilience is a buzzword now, but it's actually very important for India. And another use case which like ISAC, I think people have been talking about it, but in context of what I just said, right, can ISAC help us in saving lives? Right? That's very important for us. Okay, and that you basically sense such a disaster and can inform the vehicles crossing through that area and basically save lives. I think as a nation, that use case is of particular interest to us.
Thank you. Okay, so any question from? Okay, there is a raised hand. Can you give mic there?
Hi, good evening, everyone. My question is like, how are we planning to use AI in a way that we stay ahead of AI-powered cyber attacks? How do we implement this in our systems?
AI powered cyber
Attacks,
attack,
like
how to
attacks, like
handle that?
yeah. How do we stay? Because we will be using AI to defend ourselves, and like attackers will be using AI to attack. So how do we keep ahead, like keep ourselves ahead of them?
So the question has moved to security. How do we tackle AI powered cyber attack in a network? Anyone want to pick? Yeah.
So I can comment based on my experience in the context of Open RAN, where the vision is a lot of ML-based applications that will sit over the controllers, and and there is a huge body of work on attacking ML models, and this falls under the adversarial ML area. And in recent work, we have explored how vulnerable are these ML-based apps in Open RAN to such adversarial ML attacks. Can we tailor and create these attacks in such a way that they are potent and cannot easily be addressed with the standard defense mechanisms in the adversarial ML context? And the answer to both of these is yes. I think this is a worrying sign. So we've designed a surrogate ML model. So think, for the question that you're asking, ML to attack ML. So you can create, by passive monitoring of data in the Open RAN context, you could build a surrogate model that can then obfuscate the input to the target ML models and affect their behavior and affect network performance. And such an attack is also immune to the standard defense mechanisms. Okay, so that's one example of the potential for ML to attack ML.
Can I?
Thank you.
Maybe
Okay,
also-
please.
Maybe also to give a bit the full picture also from the standardization perspective, because this is now in the September 3GPP plenary. It has now been approved, the study item in SA3. SA3 is the working group responsible for security, and AI related security is of course one of the key focus. And there is now a current, there will be, the work will start with studies on basically how to use AI to protect against cyber attacks. And those will be basically cover two angles. So one is to detect a cyber attack, or how to protect the AI algorithm that we integrate into the network from AI then attacking those. So those will be also part of the standard work that we start basically in the coming meeting in standardization.
Yeah, thank you. Sandeep ji? Yeah,
just
please.
to add one thing, the only challenge that I see in the industry today is that AI is all evolving much fast, and we have a slow cycle for standardization. So AI will always be coming out with all the dark side of the world will always be using those methods, but only way to counter those methods is just to be stronger than your opponent. Keep all the zero trust architecture defined for your network, all the checks and securities with HTTP is defining, make sure that those latest releases are getting implemented in the network as well from the telco perspective. End use cases will always be a challenge. It is all depend on how much relevant and latest frameworks that you have implemented in the network.
So can I
please.
jump?
Yeah.
You know, I wanted to go back to the agentic AI, and then I want to use this chance to go back. Yeah. So I think this is a key point, because AI is evolving very fast, right? And we say if AI is evolving with 12, 18 months somehow schedule time, while standards, we have a a new generation every 10 years. You can imagine that if we start from this angle, the solution that will work in 2030, let's assume that the first deployment of, we expect the first deployment of 6G network at the end of 2029, beginning of 2030, then depend on the region and the fast adapter or not. But then if at that time will be suitable for the AI solution available at that time, then we will be basically dead because the evolution will be fast. And I think here is where in standard we need to have the flexibility. And here is also why it's important that agentic AI, we look at it from the natively, we should support that. And that's also part of the study because, I mean, AI for me is helped me to resolve complex problems, right? Or to resolve use cases that alone it will take a lot of time, or I will not be able to then solve. And it will be the same. So agentic AI will help us basically to address the use cases which are unknown today. So, and the only way to do this is to create a system, an AI native system that will then leverage the same technology that then is going to evolve during the same time. And that will be also I have generalized, but that is also from the security perspective. So,
thank you. So I think what he's saying is that standards should be flexible enough to adopt evolution of AI going forward. So although technology from 6G to 7G may take 10 years, but it should be flexible enough so that, I mean, all those AI evolution and other evolution can be taken care of. So we should not be very specific or very tied into the standard. Thank you for that. I think I want to move to a slightly different subject. So we had a keynote from GSMA just before our session. They were talking about spectrum need for 6G in different band, and the spectrum availability in different part of the world countries are very scarce, right? Already some of the spectrums are used by some other agency, maybe defense, maybe other departments. So there is a real need for spectrum sharing, right? And we tried in 5G dynamic spectrum sharing. I mean, it was also deployed and today people are trying, but really it has not worked. A lot of wastage happens on the side when you use. So whether AI can help on those spectrum sharing aspect, that's a open question to any one of you want to pick up.
I think there is some evidence already to suggest that there is potential for AI to aid in the spectrum sharing. So if you operate in a world where the spectrum is shared by default, then the usage of the spectrum varies in across space and across time, and to adapt the usage to match those patterns, there is some work in the research space to show that spectrum sharing in a more holistic sense, aided by AI, can help. And there is a lot of potential there in terms of further work, but there's already evidence to suggest that.
Thank you. So Pathak ji has come with something. Okay, let me ask one. We can continue. Okay.
Excuse me, I want to add one more.
You want to add? Okay. Yeah, please go ahead.
Primarily, I think one of the interesting subject when it comes to India is when it comes to spectrum sharing. Of course, spectrum is something which is very expensive thing. We all understand. And how do we share for multiple applications? One of the subject which is definitely in discussion is we have been allocating spectrum for, let's say, railways. If you look at railways, it actually the railway line passes through all parts of the country, urban area, rural area, and so on. And there's a huge amount of infrastructure that is getting created. So how do we leverage this existing infrastructure for not only serving the railway operations as well as providing network coverage to the rural area. So how do we enhance? Probably this is one subject I can see AI can actually bring a lot of changes. How do we share the spectrum? And this is one application, but there are multiple applications which I can foresee the AI can play a role based on the learning, how it can actually make sure the mission critical network is not compromised, as well as the same network is utilized for offering network services.
Yeah, so I think what we are talking about is how AI can help in enabling efficient spectrum use. We could look at a flip side in terms of how we can manage the demand through AI. And this is where semantic communication comes in. So oftentimes we take the view that demand is not to be managed, but we only worry about providing adequate supply, be it through additional spectrum or densification or greater spectrum efficiencies. I think there is a real opportunity to leverage AI in the context of semantic communication to manage the demand so that the available spectrum can go further.
Thank you. Any question from audience? Okay, so I have one more question. So we are talking about distributed AI in the sense that AI into CU, AI into DU, so AI at edge, even AI onto the devices, and of course on the core and cloud. So if you implement AI at various distributed levels, there will be a lot of compute requirement at every level. So I don't know whether, I mean, how to solve that problem of huge computational requirement at different distributed levels, and whether it is wise or, I mean, it's a capital intensive, whether that sort of result will come or not. And also maybe the device cost would increase, that will make affordability is a problem. So that's the question. Anyone want to pick up? Yeah.
I can start maybe. So I think it can be addressed from two different sides. So first of all, of course, we distribute it depending on the real-time characteristics. I'm coming back to real-time characteristics, where we have smaller models that require faster inference, and they are running on the DUs. And then we have hierarchical set of different models, and the heavier ones can run on centralized units as well. And that's one side of story. The other side of story, of course, is semantic communication, as you mentioned, and all the distillation techniques, so to make the models more efficient and to have maybe more efficient acceleration hardware.
Yeah, thank you. Yeah. Okay, so we already see some of the Qualcomm chips are having AI onto the devices. Yeah, so I think you answered that. Any question from audience? From any of the panelists? Yeah. Can somebody give mic? Yeah, thank you.
Hello, Kapil Parashar from Vyom Group. My question is with Dr. Alina. We are working with the Ministry of Startup and DPIIT. We have a consortium of startups in AI. So, as an incubation head from Ericsson, so how can you help these startups from tier 2 cities from India? This is my question to Dr. Ali.
It's a very interesting question. So he works in a department which nurture startups in India, and some of the startups working on AI, I mean, Ericsson is helping them. So how they can, I mean, solve some of our problems, or we solve some of their problems? Yeah.
I can start. I think it goes back to that clock speed of different pace of developments in standards and in AI, because it's, as you say, it's maybe half a year, 1 year time horizon, and all the startups are developing the new models, and we need to be able, in our industry, we need to be able to be so fast to be adopting those through the different technologies that we have. So I think that collaboration with startup ecosystem is key, absolutely key, because the innovation is happening out there. Innovation on AI has a very quick cycles, and we need to be able to adopt those technologies in our telecom sector very fast.
Thank you. Any more question? Right. So, okay, I think we should have uh, maybe last question from my side. So, Pathakji, you are done. Can we try to conclude? Okay, so last question. No problem. So, last question, then perhaps you can have group photograph with all of us. Okay, so my last question is like, I think we answered a bit initially that I mean when you use AI, you increase the computational load. That means the power consumptions. We has already been struggling with huge power requirement of the telecom network. So particularly the base stations, which we have lakhs and lakhs in number everywhere. So how do we tackle the energy efficiency part? For example, we always talk about like we want to energy efficient, we want a green technology, but with such a compute requirement which is energy consumption heavy, how do we solve that problem?
I think, yeah. So for telecom, we don't need such LLM kind of models, okay, which are compute intensive, and that we have to be clear that we need small language models which are not very compute intensive. So that partly solves telecom problem. That there are these the kind of tasks which we are talking about to make these AI native 6G. We are talking about small like channel estimation. Okay, so how much of energy that's going to consume that. So we need to build very specific subsystems, AI-based subsystems. That will help us in understanding like how like that will basically reduce our energy consumption. So we are not looking at very small, very heavy models. That I think that we have to be clear. Plus, what we are looking at from operator's perspective also is the inference power, not the training power. Okay, and if you go to 3GPP, people are mostly talking about inference, how much of inference power it is consumed. And I think at the end of the day, it's going to affect us because it's like somewhere energy is getting consumed. Okay, it's like an EV. Basically, you are you are reducing the pipe pollution, but you are increasing the pollution somewhere else. Okay, right? And then here also, for training, I think we 3GPP doesn't talk about training. It only talks about inference. Okay? And that's where. Plus, the key point to take back home is only like from telecom perspective is very small models which we are talking about.
Thank you. I think Sandeep want to add.
Just to add here, today when we talk about sustainability, power consumption, we are doing two mistakes here. Sustainability, we are comparing AI chipsets which are existing today, but chipset industry will not remain consistent in the current state. They will also evolve, right? At the same time, as Professor Rohit has also rightly mentioned, the compute is not required that heavy at every layer, right? There are different types of compute chipsets that are available. You need NPUs, you need CPUs, you need GPUs. Not every compute is, I would say, power hungry. At the same time, look at the telecom network.
So I think we have to conclude immediately because I have to make this in order.
Yeah, so I think it has been a great discussion. So can I have a huge round of applause for all our experts, panelists? Thank you, thank you, thank you. Can we have a quick group photograph, Pathakji? Thank you. It's okay. I think we have already completed our discussion and it was really good. And the expertise which we have today from the big OEMs like Nokia, Ericsson, from Academy, Professor, I think, oh, sorry. No, I'm talking about you and Rohit and also from SME, Rekha. Thank you. Thank you, everyone.